Good morning, class. This is our final day looking at inequalities as constraints on the Cartesian coordinate plane. You will be completing this single document, and in addition to this doc, you're going to upload a copy of your homework for the last section in Chapter 9. So, two things need to be on this assignment: this document complete, that means filled out by you, and an image of your homework where you're clearly showing your work and your solutions and circling your answers. So, emergency preparedness. So the setup for this is probably more than I don't want to. I don't know that we need to get into it a lot, but the idea is that a bunch of countries have decided that, look, if there's a natural disaster, it would be better if we kind of were prepared for it ahead of time. So we're going to pre-stage two kinds of items that will be helpful for us in a time of crisis. One of them is these medical kits. They could be they're quite substantial. I mean, the standards for what they are probably include like some beds, some tents, some supplies, personal protection supplies, maybe the ability to do some minor surgeries in one of the rooms. So it's a medical preparedness kit, and the other one is these pallets of food that are pre-prepared. So those two things, you've got the food and you've got the medical kits, and there's going to be a series of countries, and I believe the countries are labeled with letters. And for our purposes, and actually, you're going to see this. We're going to call these countries A, B, C, D, E, and I think there's one more. And there's a special request. Special assignment. A special assignment. So it's going to be countries A through E and a special assignment. And we're going to go through and we're going to read those. I'll discuss them with you, and I'm going to come up with two of the constraints for you. Your goal is to come up with all, what is it, one, two, three, all six constraints and add them onto a single graph so that you're prepared to answer a couple questions about those. Now, coming up with these constraints is not as simple as it might seem. The last time that you did this in an assignment, I would say way more than half of you were getting the constraints right. One of the things I noticed was that some of you were just looking at them as at lines, just single lines, not necessarily as inequalities. So remember, these constraints are inequalities. The lines are just the boundaries, and then you're either above or you're below that boundary, or in the case of less than or equal to or greater than or equal to, the boundaries included. So it'll be very helpful to see how our graph is set up, and when we read the constraints, it'll help you think about which values are x, which values are y, and how we're going to build them. So if you look at this, we've set up an xy plane with x being the number of food packages that are ready to be delivered, and the y-axis is the number of medical packages that are ready to be delivered. And you can see that it's scaled differently. So this is 50, 100, 150 food packs, 100, 200, 300 medical kits. So X number of food packets, Y number of medicine packages. So this is the first of six constraints. And it says, memo from your country's budget committee. Because we are spending so much money on improving our hospitals right now, our funds are very limited. We are constrained to spending up to, but not more than, $300,000. So the amount spent can be $300,000. So to me, that's got to, or equals to, right? The boundaries including the line, but it can't be more than that. So it has to be, the amount spent has to be less than that. Each food packet will cost our country $900, and each medicine package will cost $600. So I'm leaving this here just for you to kind of jot down those two ideas. The most they can spend is $300,000. Food packets will cost $900, and medicine packs will cost $600. So if I was to translate that to a constraint, thinking about X and Y and what they meant, if you recall on our graph, we had that number of food packages was X and the medical packages was Y. So I could say because each of their food packs cost $900, every single one of them, right? All the money that this expression represents how much money is spent on food. Each pack costs $900, and they buy X of them. So if they bought zero of them, it'd be $0. If they bought one, it'd be 900. If they bought two of those, it would be $1,800, right? And each medicine pack will cost $600. And that was Y. So we'll say plus 600Y. So $900 times X plus $600 times Y. Now, that's the amount of money that they're spending, right? That's the amount. If they buy one of those and two of those, that's how much they spent. If they buy none of them, that's $0. If they buy one of each, it's 1,500. Now, the amount of money that's spent has to be less than, but it can equal. And you see, I wrote it like that, and that's fine. If you want to write it like that. In Desmos, it's going to change that to an equation, but it has to be less than or equal to $300,000. All right, so that's our constraint. That's a constraint that we'll look at on the Cartesian coordinate plane. Now, to flip that into graphing form, I could clearly isolate y. I could subtract 900x from both sides and then divide both sides by 600 to get y alone. But I don't need to do that, and it's okay with me if you leave it in this form, because this will graph just fine on Desmos. So I'm going to go ahead and take that constraint and we're going to add that to our graph. So here in Desmos, I'm going to go ahead and expand my ability to type the equation. So here we are where we can type the equations. And this first one was, it was the food package was 900x plus 600y. It can equal, right? But it can be no more than, so it has to be less than or equal to. And you can see as I type that, right? Less than or equal to, it changes into that $300,000. Okay, so there's our first constraint from country A. So what this means is that country A could buy, for example, 100 food packs and 100 medical kits. They could buy 100 of each, and they wouldn't exhaust their budget. And I am thinking about a bit of arithmetic just to kind of check the reasonableness of this graph that I have. But if, for example, if I was to say I was to pick this value where my cursor is means that I would literally have 500 medical kits and 0 food packs. Well, these medical kits cost $600 each, and if I take 600 and I multiply that by 500, I get exactly $300,000, right? So they could buy 500 of these and no food, and that would work perfectly fine. And I could go down here and I could look at the other, and like clearly this I'm not exactly sure. Oh, look at that. Well, it's no one's going to buy 333 and 1/3 packages of food. But if I bought 333 food packs, that would that would come pretty close to being $300,000 at $900 each. So again, this red region represents all the XY pairs that would satisfy country A's constraints. All right, so that's one of 6 constraints. We're going to look at one more of them together. So we've got country A's constraints. Not only did we type that into our response document, but we've also got it included in our graph. Let's go down and look at country C. So one of the things that's interesting about this problem is that the cost of food packs and the cost of medicine packs varies by country, and that's just because they're sourced differently, right? So if you're buying, it could be that in your country it costs a lot less to produce something, so you can have the same equipment, but just at a lower price. So here's a memo for country C. Since our country is doing so well financially, our citizens voted that we must spend more than $540,000. Okay, so this, when I see more than, it says $540,000 is not more than $540,000. So this constraint's not including the boundary line. right? We have to spend more than this amount. Now, how do we get to spending this amount? Well, by buying two things, right? And the two things we're buying are food packages and medicine packs. Each food package will cost our country $2,000, and each medicine package will cost $3,000. All right, so let's take that information and go ahead and build our second constraint. And we're doing this for country not B, but for country C. So it says, since our country is doing so well, okay, so we're going to spend $2,000 for each of the food packs. So again, X was food, so $2,000 for each X. And then plus, we're going to be spending $3,000 for these medical kits. And our constraint is that we want to spend more than $540,000. Maybe the question is, well, why don't they just? Maybe they should just buy everything. So we want it to be this. Just say, hey, well, this is what we want. And since you guys want to spend more than everyone, why don't you just buy it for the whole world? Well, that's not that's not what's happened. We're all going to try and contribute equally, right? We're going to try and contribute number of food kits and medicine kits equally. So $540,000. So this is the second constraint we'll look at. And again, if you wanted to graph this more easily, I would say dividing both sides by 1,000 would be a phenomenal trick, right? That would make this 2x plus 3y equals, take off 3 of the zeros, 540. And that the graph would be the same, right? The boundary would be the same, and we're going to be shading um, above that. But Desmos doesn't need that, and in a way, it's kind of like, oh, Desmos is kind of making us lazy. But we do not have to isolate the y variable like that. But it's still very important that I talk about that and get you to think about the fact that if I was asking you to do this on paper and pencil, a good trick to do would be to divide both sides by 1,000 and then isolate the y. But we're just going to go ahead and pop over to Desmos, and we're going to add this constraint. So we said that each one of these cost $2,000, so $2,000 times x plus $3,000 for the medical kits, y, and we want that to be more than $540,000. Okay, so what's happened now is if you this is going to get hard to look at, so you know that you can turn off these constraints one at a time just by clicking these over here. But if you look at it, the region where both countries are able to contribute is anything in this kind of triangular region here, right? Or actually, it's not. It's got four sides. It's a quadrilateral region. So any XY pair that I picked in here would satisfy both countries at the same time. Some of them would just satisfy our original country A. Some would just be for this country C. But the ones where they overlap would be both. So if I ask all the countries to give 50 food packages and 300 medical packs, every country could do that so far of the two countries we've looked at, and it wouldn't harm their budget. It would meet their spending priorities. So I'm going to go ahead and show you the remaining constraints, and I'll read them to you, and then have you can take notes and then add those to both your doc, and then also add them to Desmos. I want to review how do you grab this graph at the end so that you can include this in your solution. So I'm going to move this up a little bit. Well, I'll leave it right there. That's good. So if I want to grab this graph, right, I kind of need to click a shared. So I'm going to hit the shared icon. Perfect. And you can see I can print this graph, I can export it, I can embed it somewhere. What I want to do is not copy a link to it, I want to export this image, right? The image is what I want. Now there's two options I have. I can download this and then I can insert this image into my document directly. Or I can come over here and I can just right click this. So on your trackpad on your Chromebook, if you hover over here and click the right mouse button, you'll have the option to copy that image. So I've just copied this image. It's probably better if you make it maybe the thick line. So I'll copy this image. So I put it on medium. And now that I've got this copied, right, what I can do is I can go over to my doc And down here it says graph with all constraints visible. Now this is it's too premature for me to do all of them because this is just 2 constraints, but I'll go ahead and paste this anyway. So to paste this, I would hit Control V. There it is. So I can now see, and I can resize this, make it a little bit smaller so that we can see it here. But now I can see the solution regions for all of the countries. Okay, and you're going to need to be able to go back and forth and look at this at Desmos to answer the questions below. But your assignment is to use the remaining 1, 2, 3, 4 constraints that I'm going to display for you, put all those constraints onto your graph, and then answer the questions below, right? So here's the questions below, and there's a part A and a part B. You're going to come down to this A, and you're going to type your response for A here, and then you're going to type your response to B right below. So your response A and B, and then a last minute proposal, and you're going to just type your response for that right below there as well. So what I'm looking for from this assignment is all the constraints typed here, all those constraints accurately reflected in Desmos on this graph, and then I'm looking for answers to A and B below. So let's go ahead and look at our final constraints so that you can get to work. Okay, so you've already seen A and B, so let's come up and look at country B. I mean, you've seen A and C, so let's look at country B. Again, feel free to pause this if you feel like I'm going too quick. You can control this. Because we are spending so much money on improving our schools right now, our funds are very limited. We are constrained to spending no more than $600,000. No more than. So if I say we're going on a field trip, you can bring pillows for comfort in the bus, but you can bring no more than 2 pillows. Are you allowed to bring 2 pillows? Yeah, because you can, it says no more than. You can bring 2 or less than 2. So this phrase no more than is clearly indicating that it's $600,000 or less than that. And how are they spending it? Their food packets cost them $500 to produce, and maybe they're an more agriculturally based country, so they've got less expensive food, and our medicine packs will cost $200. So that's A, that's B. Again, pause this so that you can go type what you need to into the doc. C says, since our country is doing so well financially, our citizens voted that we must spend more than $900,000 in aid to other countries. Each food packet will cost our country $5,000, and each medicine package will cost $2,000. All right, that's the restraint for country D. Go ahead and pause and make sure you get that in there. And then country E says, luckily our country has many medical supplies, so there's no limit to the number of medicine packs we can offer. However, due to farming restrictions in our country, we are constrained to donating fewer than 250 food packages in order to feed our own people. So that is an interesting constraint, and I want you to think about that. They're not talking about money. They apparently don't care about the money. So medical supplies, there's no limit. However, they are limiting one of those variables, right? So think about what this would look like. We're looking at X values that are less than 250. So it's an interesting constraint to write because because one of the variables is not used. So play around with that and then keep coming back and look at the constraint you wrote, look at the graph, and then see does it make sense with this constraint. And then finally, the special assignment, special note, since our country is a member of the Emergency Fund Committee, I have a special job for you. We are expecting food shortages in the near future because of the severe drought in the Sudan. Each country must give at least 100 food packages. So this is kind of related to country E, in that this constraint only affects one of the 2 variables, right? So they're saying that that you have to give at least 100 food packages, and this one was saying that you have to give fewer than 250. By the way, that word "at least," the thing I'm curious is, do you get the constraint right? Right? Does it include 100? Does at least 100 include 100? And then at least would it be? Is it more than 100, or is at least 100. So just say to yourself, look, I need to bring at least 2 boxes of donuts. I need to bring at least 2 boxes of donuts, right? So you think about how many boxes of donuts you need to bring. All right, so that's it. You're going to, I hope you hit pause and then you use that to build all of those constraints. And again, on this document, you're going to complete this document entirely, and then you're going to upload an additional item to the assignment. You're going to upload this additional uh, image of your homework for the very last section in the textbook. All right, this is Mr. Roberts. I hope to see you, maybe some of you at 10 o'clock today.